to name one U.S. firm, has tested Visimer systems that can be adopted now to achieve a 1/1000th G force. This is not a 2030 project. It should be a 2020 project. To steal a JFK quote, which I'm sure you would be proud to make, the vision is still alive. Mars now. We need a goal to put a man on Mars before the decade is out. And some references. And I have reached the end of my talk. Yes, sir.
Dr. Zuber, he likes to use the figure 200 megawatts.
I understand that, yes.
So,
I can only refer you to the phone number I'm going to give you. 1-509-371-9524. He is my partner in crime and has stood me up for this. So, Dr. James.
You're suggesting that the engine pulse technology exists today to undertake the 100G?
That's what my partner suggests, yes. Yes, sir.
The most economical version of the ship you have up there using the atomic engine one.
Mm-hmm.
How much mass would that be? And you're talking about 5 ships, right?
Yes, and I propose a system for getting people into orbit, or getting us into low orbit, but that's my second talk, which is 2 p.m. tomorrow.
Okay, so, but then how much is one of those ships in mass?
I can't tell you right now. We're suggesting this.
now you see the Russians already have a nuclear
1.2 megawatts.
small nuclear.
1.2 megawatts. That's correct.
And how long has this been going on?
They do their ocean surveillance satellites with that. I assume at least 6 are in orbit.
Wow. This back out of the early 70s. A long time. These are different than the totals.
Yes, these are bigger.
Yeah, but they're not manned, are they? None of them are manned.
No, these are not manned. So there would have to be some aurelation done there, and there is developmental issues that have to be addressed, and I admit that. So, but I think we could do it. Yes.
Do you know what the power to weight ratio on these?
I do not know, but they certainly took a large rocket to put it into orbit. It may also be necessary to do a Saturn type or one of the primary rockets to get something like that up there, but there are other ways of getting the rest of it there that would be more economical.
Right, but I mean, there's a difference between what might be acceptable for something that's just in LEO versus something that actually has a delta V requirement to it. And then your thrust to weight ratio is going to be important, whereas
Yes,
a LEO orbit,
that's correct.
it doesn't matter what the thrust to weight ratio is because you're not thrusting.
That's correct.
So,
It's just using the energy in a different way. Yes, sir.
So would this technology be more efficient or less expensive than the Nerva type system?
I'm sorry?
Nerva type propulsion?
Cold fission rocket.
The old 900 seconds is going to get all 75,000 pound thrust engines, and that's built back in the 70s.
Okay, I'm not sure. I don't know. I'm not familiar with that historical. Yes, sir.
My dad wrote that Nerva. Yeah, it would be totally different. You're talking less efficient, but it's more expensive for us.
Less thrust, more efficiency.
Right.
Yeah.
This is a nuclear-powered ion drive, not a nuclear rocket.
Right. Exactly. We want to throw our mass backwards as economically as possible. So, ion or ad astra or some other method needs to be done to create to use that mass effectively.
We've got about 3 minutes left.
Yes, sir.
So, for analyzing these things in more detail, do you have any of the actual graphs of payload fraction per transit time?
Yes, sir.
You don't? Okay.
All righty. Thank you for your time
No questions? Okay.
and your patience.